Hello students, welcome to Narayan PU College online classes. So continuation and answer a textbook question. Draw the structures of all 8 structural isomers that have molecular formula C5H11Br and name each isomer according to the IUPAC system, and you have to write the 8 structural isomer for this compound, and then you have to write the each isomer IUPAC name and classify them primary, secondary and tertiary. I will not discuss here IUPAC name. Why? Because we have already previously discussed. So now, and we will write the 8 structural isomers and we will classify them primary, secondary and tertiary. Clear? So compound given is C5H11Br. Means this is, you know that C5H12 is a alkane. And if you replace one hydrogen here, and you will get C5H11Br. Clear? So that's why here in this compound there will be no double bond and there will be no cyclic ring. Why? Because it is an alkane. C5H12, one hydrogen replaced by one bromine. So we have to write here structural isomers. Important. Why I am saying here, sometimes directly in the competitive examination they may ask, and how many structural isomers can be written for this molecular formula compound. So how many you have to write? 8. In that way also they will ask. Clear? And now you know that alkane and 5 carbon atoms, 1, 2, 3, 4, 5, and to this bromine is added. This is one isomer, structural isomer. Clear? See, 5 carbon, 1, 2, 3, 4, 5 carbon. Now this is 1, this is 2, 3, 4, 5. Now I can put the bromine on the second carbon, then you will get another structural isomer. Shall I write that one? This is 1, 2, 3, 4, 5, and now 1, 2, 3, 4, 5. Now I will write the bromine on second position. This is another isomer. Now I will write on the third position. Then I will get another isomer. 1, 2, 3, 4, 5. Now I will write bromine here. Clear? This is 1 bromopentane, 2 bromopentane, and this is 3 bromopentane. Shall I write on the 4th carbon? No, I cannot write. If I write here on the 4th carbon, bromine here, this compound and this compound is same. So that's why we should not write this is. Clear? So 5 carbon containing here only 1, 2, 3. Next I will write 4 carbons here. 1, 2, 3, 4. But compound having how many carbons? 5. I will put here one another carbon. Total how many carbons are there? 5. Now I will put here bromine. Clear? This is one isomer. You see, if I put bromine here or here, both are same only. So that's why I cannot put the bromine here. If I put the bromine here, I will get the same, again same compound only. So next what I will do, and here this bromine I will keep here. Then I will get the another isomer. This is the bromine. Shall I write this one? Second one. Yes. Now third one. I will keep bromine here. This is another compound. This, see, 1, 2, 3. Another. If I keep bromine here, then I will get another one compound. This is bromine. Clear? 4 possibilities completed or not? Yes. Next one. This is 5-member lengthy chain and it is a 4-member. Last one is I will put 3-member. 1, but 5 carbons I will keep one here and I will keep another one here. Clear? Now I have to put the bromine. If I put bromine here, this is the compound. If I put bromine here or any of this carbon, then you will get the same compound only. You see, suppose if I put bromine here, both are same compounds only. Clear? So that's why you could not write this. Clear? So now you see how many structural isomers we have? 1 and 2, 3, 4, 5, 6, 7 and 8. Clear? So how many structural isomers we can write here? Total 8 structural isomers we can write for the compound C5H11Br. Clear? Now IUPAC name we have previously discussed. Again I will not discuss here IUPAC name of these compounds. And we have to classify them primary, secondary, tertiary bromide. Previous we have discussed what is the primary, what is the secondary, what is the tertiary. Now this bromine attached carbon is attached to only one carbon, so that's why the first compound is a primary. And second, bromine attached carbon is attached to two carbons, so that's why it is a secondary. And here also this is attached to two carbons, it is a secondary. Now here this is primary. Why? Because bromine attached carbon is attached to only one carbon, so that's why it is a primary. And this carbon 1, 2, 3, so that's why it is a tertiary. And this is 1, 2, so it is a secondary. And this is only one carbon, so it is a primary. And here this is bromine attached, only attached to one carbon, so it is a primary. Clear? So that's why these are the 8 structural isomers, and we have classified them as a primary, secondary, and tertiary. That homework you have to write is IUPAC names of all these compounds. Next one is nature of CX bond. Next one is what it is, nature of CX bond. Now you know that here halogen atom is in the alkyl halide. Halogen atom is attached to the carbon here. So in this case you know that, and halogen is more electronegative compared to the carbon. So that's why, and these pair of electrons will be taken by more electronegative atom, that is the halogen. So what happened in this case, when the electrons shifted to the more electronegative atom, then in this case carbon acquires the partial positive charge and halogen atom acquires the positive partial negative charge. So the CX bond in the alkyl halide is polarized. Is what it is, polarized. And this bond we can call as a polar bond between the C and X bond. And you know that the polarity of this bond or the compound can be determined or calculated by dipole moment. Dipole moment. Clear? What is the dipole moment? You might have studied in the first year. And what is the dipole moment means? And charge into distance. Charge into distance. Clear? So now if I write here one important dipole moment order, it is there in the NCERT textbook, and most 2-3 times that same question asked in the competitive examination also. So now they have given here fluoromethane and chloromethane, bromomethane, iodomethane. So write the order of dipole moment of this compound. The polarity of the compound is calculated by dipole moment. What is the dipole moment here? Charge into density. And you have to write the order. You know that dipole moment is directly proportional to electronegativity. If electronegativity of the element increases, dipole moment also increases. Clear? Now you see, if you take these 4 compounds, and fluorine is more electronegative than the chlorine, bromine and iodine, so that's why, and CH3F should have greater dipole moment compared to the CH3Cl, CH3Br and CH3I. This should be the order, but this is not the correct order for these compounds. What is the correct order? The correct order of this is CH3Cl, CH3F, CH3Br and CH3I. This is the correct order. So why it is like this? Because you know that dipole moment is dependent upon which one? Charge and density. The charge and distance. Distance between the what? C and X bond. Clear? You know that here in this one I have already mentioned halogen atom acquires the positive negative charge, carbon acquires the partial positive charge. Clear? In this case, what happened you see? If I take this is also negative and this is positive. And what is the bond length order? CH3I. If you take in this one, this bond length is longest. but in this case CH3F, this bond length is smallest. Yeah, but you know charges are similar here, negative charges, but you have to consider here charge density. Charge density on the fluorine atom is highest compared to the charge density on the iodine. Even though having the same 1 unit negative charge, but charge density on the smallest atom is always highest. Clear? How it will? Let me take one simple example to explain this. Suppose take and let just assume the 5-year boy, and you know 5-year boy means, and he is very sharp fellow, and take some younger boy, so he is 18 or 17-year boy here. Just assume it is a fluorine and it is a iodine. Clear? So you know that I have given here 1 mango to each. I have given 1 mango to small boy, and I have given 1 mango to younger boy. Clear? And this 1 mango is more than enough for the small boy, but 1 mango is not enough for this younger boy. Why? Because you know the size of the stomach for the smallest boy is very small, and for the younger boy is large. So if he take this 1 mango, and his stomach will be full, and here this stomach will not be full because he needs more. I have given only 1 mango for this boy, and this boy also 1 mango. Means, and here the charge distribution will be highest, and here it is charge is totally distributed. Charge is distributed throughout the fluorine atom, but here charge is not distributed throughout the iodine atom. Why? Because size is big and here size is small. So that's why. And if the small charge ion is small, and it have the highest charge density, so that's why here charge is highest, but here charge is lowest, charge density lowest. Clear? But we have to multiply. If you see, and length is small, but charge density will be high, and here length is longest, but and charge density is lowest. So if you take and CH3Cl, and here charge is higher and length also it is longer. So if you multiply these two for the CH3Cl, you will get the more dipole moment will be, you will get highest. Means here charge is lowest, length is longest, and here charge length is smallest, charge is highest, and but this compound will be, and you know it is balanced both the charge and you know it is length. So that's why this multiplication will come highest for this compound, CH3Cl compound. This multiplication will come highest. So that's why dipole moment will be highest for the CH3Cl than the CH3F. That is the reason. Clear? So that's why. And dipole moment, this is very important question, and competitive examination also this question it is already asked. So that's why you have to be careful.